A particle moves along an arc and it follows the law L is equal to A sine omega t, where L is the displacement along the arc. So basically, it's the distance it travels along the arc. We need to find the total acceleration of the particle at points L is equal to 0 and L is equal to plus minus A. And we need to find the minimum value of, okay, let's see the second part later. First, let's see what happens at L is equal to 0 and L is equal to plus minus A. So you see L is A sine omega t. So at t is equal to 0, L is equal to 0. So particle starts at L is equal to 0. I mean, our time starts at L is equal to 0. The particle may already have some speed. And what's the maximum L it can reach? That will be when sine omega t is 1 or minus 1, right? So maximum L can be plus A and minus A. So that's where he is asking the value of total acceleration. So at the extreme points and at the mean position. So let's call it a mean position. So initially at t is equal to 0, the particle was here and then it will reach its maximum end here. So here this path length is L. Then it will come back and go to this point, and then it will again come back and go to this point, and will do to and fro like this. So later you will study in SHM, then this equation is actually that of SHM, but instead of a circular path you have a straight path. The particle just does the harmonic motion like this. But here they are making it do the harmonic motion on a circular path. So this is the mean position, this is the top extreme position. So here v is equal to 0 because it will stop and then come back, and here also v is going to be 0. And at mean position what will happen? So let's see that. So from our equation he has given the L. So from L we can find out everything by differentiating. So let's do that. L is equal to A sine omega t. So v is dl by dt is equal to A omega cos omega t. Differentiate it again, and AT, so tangential acceleration, is minus A omega square sine omega t. So differentiating this. So total acceleration he's asking, so that will be root an square plus at square. An is v square by r, so this will be v square by r whole square. Let me write that. So v square by r whole square plus at square. So here let's just look at the terms of v square by r and at. At the mean position, because they are asking at L is equal to 0 and L is equal to plus minus A. So at mean position, the velocity, so we'll see here, t is equal to 0. So when t is equal to 0, v is A omega. So v square r will be A square omega square by r. And at t is equal to 0, what will be at? So let's see that. So at t is equal to 0, this terms become 0, so at is 0. And at extreme positions p and q, what will be the v square by r? So at extreme position, this will be the maximum, which means omega t is plus minus 90. So cos omega t is 0, so v is 0. So v square by r is 0. And at, which is this quantity, so this will be A omega square. So I'm just writing the magnitude here, so this will become A omega square. So net acceleration at O will be just A square omega square by r. So because in these two terms this will be 0, and at P and Q the magnitude will be A omega square. So this is the answer of the first part, total acceleration. Now let's see the minimum value of total acceleration. So we will write, these are at the extremes, but if you take any point in between, its acceleration you have to write in terms of theta, I mean omega t. So we will again do an square plus at square, this is the net acceleration, and an will be v square by r, so we'll put the value of v there, and at we'll just put this value. So when we do that, we get this term, and we simplify, we get this. So here I don't have a space to solve, so but you can do it. You can just write sine square omega t as 1 minus cos square omega t. Cos square omega t you can put as a variable, some y or z, and just differentiate it to find the minimum value. And you will see that minimum value comes at cos omega t is equal to r by root 2a. So when you put that value here in the same equation, you will get the a minimum as this. And if the same value you put here, so cos omega t is r by root 2a. So this will be a into root of 1 minus cos square omega t. So if you put that value there, then you will get at what L a is minimum. So that will be the answer of our second part. So I understand there's a lot of clutter here, but I wanted to do it in the single sheet. So pardon me. All right.